right, well, welcome back to math. You'll notice on your screen I'm still in lesson 7. So we are going to look at lesson 7.6. I just want to do a quick review. I know yesterday some of you had a hard time with the video, and I just kind of want to make sure we understand what we're doing before we move on. We're going to look at Mod 6.1, Lesson 7. We are on the problem set here, which happens to be page S27. Okay, so we'll give you a minute to get yourself settled. We're going to go ahead and look at these two problems to make sure everybody understands. Problem number 1 says that Maritza is baking cookies to bring to school and share with her friends on her birthday. The recipe requires 3 eggs for every 2 cups of sugar. To have enough cookies for all of her friends, Maritza determined she would need 12 eggs. If her mom bought 6 cups of sugar, does Maritza have enough sugar to make the cookies? All right, well, let's look. Let's find the ratio. Well, we already know what the recipe calls for. The recipe calls for 3 eggs for every 2 cups of sugar. That's our ratio, so that's what we're going to write first. All right, so we're going to come down here, and I'm just going to I'm going to split the page here in half, so we're going to look at problem number 1. Let's make our ratio. We're going to do 3 eggs to 2 cups. So our ratio is 3 eggs. I'm going to put labels on these so we make sure we understand. Okay, there's our ratio. 3 eggs to 2 cups. 2 cups of sugar. We also know that she has determined she would need 12 eggs. So I have here 12 eggs. So I need to find out how many cups of sugar. Well, if you recall earlier with our peanut butter, we had to make sure wherever we have extra crunchy, we had extra crunchy on top, we kept it on top. We're going to do the same thing here. We're talking about 12 eggs, so we want to keep eggs on top. We can't put it on the bottom. So we're going to say we're going from 3 eggs to 12 eggs. Now we need to determine 3 times what is 12. Well, most of us know that it's 3 times 4. And yesterday we learned that we have to do the same with the bottom. So according to this, 2 times 4 is 8 cups. Ooh, looks like that might be a problem because it says here, if her mom bought 6 cups of sugar, does Maritza have enough sugar to make the cookies? And the answer is no, she does not. Okay, let's look at number 2 real quick. Hamza bought 8 gallons of brown paint to paint his kitchen and dining room. Unfortunately, when Hamza started painting, he thought the paint was too dark for his house. So he wanted to make it lighter. The store manager would not let Hamza return the paint, but did inform him that if he used 1/4 of a gallon of white paint mixed with 2 gallons of brown paint, he would get the shade of brown he desired. If Hamza decided to take this approach, how many gallons of white paint would Hamza have to buy to lighten the 8 gallons of brown paint? Okay, well, I'm going to go back here. I know I've got some different things. I've got 8 gallons of brown paint, but I know that we found out that we need to make this ratio here. We need to do 1/4 of a gallon of white paint mixed with 2 gallons of brown paint. So I know right now my ratio that I'm looking at is we're looking at, let's say, white paint and brown paint. We know here that we're supposed to have a 1/4 gallon of white paint. Well, I'm going to take this 1/4, and I know that 1/4 is actually the same as 25 hundredths. So I'm just going to change that for my sake because it'll make it easier. So I'm changing that to 25 hundredths. And then it says 2 gallons of brown, so the 2 is going to go with the brown. Okay, so let's see. We know that we have a total of 8 gallons here of brown paint. Brown paint. Is brown paint going to go on the top or the bottom? It has to stay on the bottom. And we know that it's 8. So let's see. 2 times what is 8? 2 times 4. So now we have to take 25 hundredths times 4. I like to think of decimals in terms of money, and if I think about this as quarters, and I'm taking quarters times 4, most of us know that quarters times 4 is $1. We're not talking money, however. We're wanting to know how many gallons of white paint, and so we found our answer would be 1 gallon. Okay, we're going to continue working with ratios and equivalent ratios and values. We're going to turn over here to lesson 8. We're looking at equivalent ratios defined through the value of a ratio. For those of you that paid attention yesterday, we talked about the word value, and value basically is taking a ratio and reducing it. You might need your factor lists to help you do that if you don't know your multiplication facts. So we have to circle any equivalent ratios from the list below. Let's see. We have here 1 to 2 and 5 to 10. I'm going to go over here and I'm going to write 1 to 2 this way. And I'm going to write 5 to 10 this way. I have 6 over 16 and 12 and 32. So I'm going to look at all of my ratios. All I did was I took the ratio and I changed it into a fraction form. And I'm going to see if I can find the value. Well, obviously I can't find the value. This is as low as it goes because it already has the 1. However, 5 and 10, I think I probably could reduce 5 and 10. Obviously, if I look here at my 5s and I look at my 10s, what do they have in common? They have the 5 in common. So I'm going to actually divide both of these by 5. And let's see what happens. 5 divided by 5 is 1, and 10 divided by 5 is 2. If you notice this, these two have equivalent values. So I'm going to circle these two. Let's see if we can check out this one. 6 and 16. 6, here's the factors for 6. 1, 2, 3, 6. 1, 2, 4, 8. Looks like it's 2 again. So let's divide this one by 2. 6 divided by 2 is 3, and 16 divided by 2 is 8. All right, so here's the value. Let's see if this one has the same value. 12 and 32. Here's my factors for 12. And here's my factors for 32. It looks like the largest factor we have happens to be a 4. All right, well, let's see what happens. We're going to divide these by 4. 12 divided by 4, that's 3. And 32 divided by 4 is 8. They are equivalent. They have equivalent values. Their values are the same. So these would be equivalent ratios. Okay, let's move down here where it says, find the value of the following ratios. Leave your answer as a fraction, but rewrite the fraction using the largest possible unit. So we already found value. We already did all the work up here. As long as you wrote all this down, we already found the value. What's the value of 1 to 2? Well, it's 1/2. That's as low as it will go. 5 to 10, we found out that the value up here was 1/2 as well. 6 to 16, when we found a common factor, we were able to reduce it to get the value of 3/8. And the last one here, 12 over 32, we found the factor 4 went into both of them, which gave us a value of 3/8. All right, so if you notice here for my next question, it says, what do you notice about the value of the equivalent ratios? Well, if you notice that the values are the same. So I said the value of the ratio is the same for equivalent ratios. We found out that these two ratios are equivalent because their values were both 1/2. We found out that these two ratios were equivalent because their values were both 3/8. So go ahead and write here, the value of the ratio is the same for equivalent ratios. All right, exercise 2. Here's the theorem. The theorem is, if two ratios are equivalent, then they have the same value. So for example, if I would give you these two ratios, 21 to 49 and 15 to 35. If you look at my two ratios, right now they do not look equivalent. The numbers aren't the same. I would like for you to see if you could find the value of these two ratios. Find the value. Remember, value means to reduce the fraction. I like to take the ratio and I like to write it this way. And I'm going to do the same thing with this one. This way it's easier for me to see if I can reduce them. So I need to find a common factor for 21 and 49. 21, 49, looks like they have a common factor of 7. So I'm going to divide them both by 7. 21 divided by 7. 7 times 3 is 21. 49 divided by 7 would be 7. All right, so we have a value here of 3/7. Let's see what the value is over here. We're going to look at 15 and 35. Looks like the common factor that they have is the number 5. So I'm going to write here, we're going to divide by 5. 15 divided by 5 is 5 times 3. And 15, or 5 goes into 35, and I think 5 times 7. So you will notice the values are exactly the same. Because the values are the same, that means here we have equivalent ratios. All right, let's go on to the next page. All right, exercise 3. Tavon is training for a duathlon, which is a race that consists of running and cycling. The cycling leg is longer than the running leg of the race. So while Tavon trains, he rides his bike more than he runs. During training, here's our ratio. Tavon runs 4 miles. So we're going to run 4 miles. For every 14 miles he rides his bike. There's our ratio. Letter A, identify the ratio associated with this problem and find its value. Well, I want to go ahead and make sure we understand we have 4 miles to 14. 4 miles, we probably should say 4 miles, runs 4 miles to 14, and we have bikes miles. I have to identify the ratio, so I have the numbers 4 and 14. This is running, this is biking, but remember ratio just is the numbers, so I'm going to put my numbers as this, 4 to 14. Now it wants me to find the value. Value means I have to reduce it. Now I could leave it in this form here and write the ratio here if I know it, or I can change it to a fraction and see if I can reduce it that way. The nice thing about 4 and 14 is they're even numbers. And if I need to pull out my factor sheet, I can, but I will notice that 4 and 14, since they're both even, have the number 2. So I'm going to divide these both by a 2. And 7. So the value is 2 to 7. I can either write it this way, or I can write it this way. This is my value. This is as low as the ratio 4 and 14 will go. Okay, let's move down to B. Using the value of each ratio to solve the following. So we're going to have to use this 2 and 7. When Tavon completed all of his training for the duathlon, the ratio of total number of miles he ran to total number of miles he cycled was 80 to 280. Is this consistent with Tavon's training schedule? All right, so we obviously have a ratio right here, but the most important thing is we have to figure out what the ratio goes for, correct? We already know we have 2 to 7, and remember 2 goes with the miles that were ran, and 7 goes with the biking. So we have to make sure that stays in that order. It says here the ratio of the total miles he ran. Oh, good. So ran. We got running first. And number of miles he cycled, that was second. So we still have it in the same order. So we're going to go ahead and use our value here, which was 2 to 7. And we're going to go ahead and kind of keep our label off to the side just to make sure we know that this is running and this is biking. Just kind of a little note for us. And what we want to see is he consistent? Consistent means are we going to have an equivalent ratio here? So we're going to have 80, and remember 80 goes with our running, so that's going to stay on the top. So he's running there, and then we have 280 for biking, so that's going to go on the bottom. So we have to figure out if these are going to be equivalent ratios. Are we going to be able to multiply something here and have it be the same number up here? Okay. We can also do, from earlier, I could also do it this way. Keep it as a ratio this direction and just say, okay, 2 times what is 80 and 7 times what is 280. So we're doing the same thing. It just depends upon which way you like better. Well, we're going to have to solve this. I know that 2 times 40 equals 80. Okay, so I know that that's true. And how do I know that's true? Well, I can do it right here. And that worked. So I have to decide, is 40 going to work down here? Well, let's see. It does work. Okay, so that means when it says, is this consistent with Tavon's training schedule? It is consistent because we basically have made what we call an equivalent ratio. All right, so if you notice here, I quickly put up here in our corner where we wanted to know if this was consistent and explaining. Well, I said, yes, it's consistent. And I said the ratio of 80 to 280, which was the ratio that they gave to us, we proved that it has a value of 2 to 7. Okay, we were able to find the factor that worked for both of them. Okay, let's go down to problem C. In one training session, Tavon ran 4 miles and cycled 7 miles. There's our ratio. We're going to have to remember this. Did this training session represent an equivalent ratio of the distance he ran to the distance he cycled? So we need to find out if this 4 to 7 is consistent with what he's been doing from the beginning. So we have the 4 miles ran. Okay, put here ran 4 miles. And here we have cycled, which is the bicycle. And that would be 7. And we want to see if that's consistent with up here, our 2 to 7. So we're going to keep the 2 on the top because that goes with the running, and the 7 on the bottom. We need to find out what we can. Oh, it looks like we're going to have to go this way with our arrows. I know that 2 times 2 is 4. And 7 times 1 is 7. These two aren't the same. Well, let's try, what if I did it this way? We had the value of 2 to 7. And I have the ratio here of 4 to 7. We'll do our little Wonder Woman here. 2 times 2 is 4. 7 times 1 is 7. So this is not consistent. When it says, did his training session represent an equivalent ratio of the distance he ran to the distance he cycled? It did not. It was not consistent. As we can see, these two numbers are not the same. So these ratios here are not equivalent. They did not have the same value. Okay, so for today, we are looking at equivalent ratios and values. Once you are finished with this lesson, you can go ahead and work on the homework that should be attached.